Welcome. In this course, we'll be learning everything about network cabling. So, what exactly does network cabling refer to? Essentially, it's creating and setting up a number of cables to transfer data from point A to point B. As an IT technician, this means knowing cable categories, having all the right tools, knowing wiring and color coding, constantly cutting and splicing cable, repetitively testing connections, and much more. This course is going to cover everything from creating functional cables from scratch to signal testing them and checking our work. By the end of the course, you'll know network wiring inside and out. So without further introduction, let's just get right into it and learn a little bit more about the cable we'll be working with. So to start off, the one and only cable that we use for networking is called the Ethernet cable. That being said, there are also several categories of Ethernet cables. They're referred to as CAT for shorthand. There's Cat5, Cat5e, Cat6, Cat6a, Cat7, and more. I'll start off by saying Cat5 is obsolete. Why? Well, it has 100 megabyte transfer speed being the amount of data it can transfer at once. And when you compare that to today's most common cable, the Cat5e cable, which can support up to 1000 megabyte per second transfer speed, you'll see who's the clear winner. Both have 100 meter length limitations, which means that they can run for 100 meters or 328 feet without performance defects. If you create a Cat5e cable that's longer than 100 meters, you're going to start seeing some performance issues. For most of today's networks, Cat5e is really all you need. Most home and small business networks aren't even capable of 1000 megabyte transfer speeds. If you're out doing a cabling job and you want to future-proof the building you're cabling, you might want to opt for Cat6 or Cat6a, which are approved for much higher speeds. They're still the same cable, just improved so that the interferences between the inner wires are kept to a minimum. That's really all there is to these higher category cables. All Ethernet cords, regardless of category, contain the same 8 wires. It's how they're arranged that change up their speed and latency. So, in order to appreciate Cat7, let me quickly go over the previous categories and show you how they've improved. So, the Category 5 cable has 8 inner wires, but it has 2 twisted pairs inside. The twisting method is what helps keep out interference. Now we look at the Category 5e. It's got the same 8 inner wires with all wires twisted, so we have 4 pairs of twisted wires. This reduces interference and crosstalk even more. The Category 6 cable, the same 8 wires, but this time instead of twisted pairs, there's a plastic rod running through the middle of the cable to keep every cable as far apart as possible. And the plastic rod method turned out to be pretty useful because Cat6 cables can now handle up to 10 gigabyte transfer speeds. And then we have the Cat6a cables, which have double the frequency of Cat6. Frequency being the amount of data it can carry at once. So how does Cat6a do this? There's a thicker plastic rod. The wires are carefully and precisely twisted around the plastic rod. And on top of that, the shielding itself has grooves to further separate the space between wires. As a result, they're also much heavier, thicker, and of course more expensive. Now we'll get to the Cat7 cables. This category of cable actually puts a shielding around each of the 8 inner wires inside, which even further limits interference. They're still rated at 10 gigabytes, but they've been shown to handle up to 100 gigabyte speeds in lab environments. They also have more than double the frequency of Cat6a cables. So Cat7 cables are truly useless to the majority of us, but for those out there with server farms and large data centers, they could prove useful. In my opinion, for most of us, there's no need to go past Cat6a, even for future proofing. But as always, if you or your client doesn't care about cost, then go for it. The last type of Ethernet cord I want to mention are plenum cables. Plenum just refers to the shielding, so any category cable can come with plenum shielding. They're strictly used for cable that's run through vents or other areas that are subject to extreme conditions. That's because these plenum cables are designed to not release toxic fumes if they're heated or if they catch fire. They're also much more expensive. So don't plan on getting plenum cables unless you plan on running your cables through anything like heating ducts or piping. In this course, I'll be demonstrating everything using Cat5e cables. Don't worry though, like I mentioned, all cables have the same 8 inner wires inside. So everything I show you will work the same for all categories above Cat5. So now that you have an idea of the different Ethernet categories, let's cut open some cable and see what's inside. So now I'm going to be showing you the inner wirings of an Ethernet cord. I'm going to be doing that by splicing open a patch cable, and a patch cable is basically just a really short Ethernet cable that we use for testing. And we're even going to learn how to make a patch cable in one of the later lectures. So for now, I'm going to be cutting off the connector of this cable. You can see that all we're left with now is the wiring and the sheath. The sheath being the rubbery shield that keeps the wires inside. So now I'm going to be cutting in a little bit into the sheath so that I can actually expose the inner wiring. So just slowly saw on the sheath until it starts to give and you can rip it off. Once you start to see a few holes forming, focus on a different area and just pull it right off like this. Once you rip it off, you see that there's a nylon cord inside. This is what's called a rip cord, and it's there so that you can efficiently rip off a larger portion of the sheath without cutting the cable. I'll also go into this a little bit more in detail later. But these are your inner wirings. You have 4 pairs of twisted wires and your nylon cord. These wires are twisted so that they keep out interference. We have a brown and light brown, green and light green, orange and light orange, and blue and white blue. We'll be getting to the color coordinations of jacks and connectors in future lectures. When we actually do connect our jacks and connectors, we need to untie these 8 wires. So untwisted, there are 8 wires that help in data transfer. Now that we've seen everything that's actually inside the cable, let's take a closer look at the jacks and connectors. So here we have a bag of RJ45 connectors, or your Ethernet connectors. This is what we're going to be connecting our networking wires into. This is the tip of the connector, and this is the back end where you actually install your wiring when you're crimping on a connector. These RJ45 cables look somewhat similar to our telephone wires, which are RJ11 cables. Make sure when you purchase your connectors and your jacks, make sure they are RJ45s and not RJ11 telephone wires. You can see that the Ethernet cords are pretty much a rectangle, while RJ11 cables are like squares. So here we have our jack. The first thing that you'll notice is that there's an A pattern and a B pattern. There's no real difference between the two sides in terms of speed or reliability, but keep in mind that we've defaulted to the B pattern in the USA. So if you're doing a cabling job in the US, always choose B. If you're elsewhere, you'll want to consult those you're wiring for, and if you're doing it in your own home, just make sure that all the patterns that you use are the same in all the jacks you install. So for example, if you do choose the A pattern, make sure that every single jack in your house or building is A. You'll see that this jack's a Cat5e jack. No matter what you're wiring, whether it be a category 5, 6, or 7, the installation technique for these jacks will always stay the same. The color patterns on the jacks could sometimes differ, but the installation technique itself will never change. And that's really all I have to say about jacks. You'll learn more about them when you actually see me installing one of these. So the first thing we're going to take a look at is this thing called the crimper tool. It has a few main functions, the main being that it crimps an RJ45 connector securely to a cable. You'll see that it has a pair of blades up here, the crimper section where you insert the connector, and another pair of blades down here. These blades are used to cut wires evenly, which are kind of hard to do with scissors. It's a fairly simple device. You just squeeze it to crimp your tools or cut wires. One thing that I'll mention is that though all crimpers are basically the same, there's a reason that some are higher priced than others. The only real difference is that the higher end tools are easier to use, easier to squeeze. So for example, if you go out and do a cabling job and you need to crimp 20 to 50 connectors, Your hands are going to get tired really quickly. So if you plan on doing this professionally and out in the field, make sure you get a good crimper. But if you're only planning on doing a couple of installs here and there, the cheap ones will do just fine. They'll get the job done for sure. That's pretty much all there is to the crimper tool. You'll see it in action in section 5 when we start creating patch cables. The next tool I'm going to talk about is something called an impact tool or punch down tool. These things are used to punch down and secure wire to a jack. You'll see how it works in section 5 when we actually get to installing jacks. The only thing worth mentioning right now is that when you're buying these, make sure you get the right size blade. Ethernet cabling requires a 110 size blade, so make sure you get the 110 and not the 66 blade, which is used for voice and Cat3 cables. Sometimes these tools will even come with both blades. These are the most commonly used types of blades at the moment because they're easy to use, they're effective, and they're highly interchangeable. You'll see that one side has a cutter or a pointed edge. This is used to simultaneously cut wire as you're punching it. You'll see that in action later too. So that's pretty much it for the impact tool. The only thing to keep in mind is get the right size blade. A 110 blade. The next tool in our toolkit is a good pair of scissors. For the purpose of this video, I'm going to be using kitchen scissors because I can't find my good scissors, but make sure you get a good pair of electrician scissors if you're going to be doing this out in the field. On the occasion that you don't have electrician scissors, normal ones will suffice, as long as they're tough enough to cut through cable. Good electrician scissors can run you anywhere from $20 to $40, but they're way better at cutting cables. Whether it be Ethernet cables or those tough coax cables, good electrician scissors will cut right through them. As you can see, they still get the job done. Like the crimper tool, good scissors really pay off when you're doing larger jobs or more frequent jobs. Having quality instruments are going to shave off a lot of time and effort from your project. Lastly, we have our cable tester. This is a special device that we use to test our cables to make sure that they're created and connected properly. When you're doing a rather large cabling job, you need to make sure that every single cable that you create is tested before installing in the building. It's very easy to make minor mistakes when you're connecting on connectors, and one small mistake can end to a bunch of dysfunctional connections. So this is a very important tool to have. I'll show you how it works really quick using this patch cable. Insert one end into the terminator and the other end into the main device. No matter what kind of tester you have, no matter what brand or model it is, it's always going to have a terminator port and a main port. So I'm going to turn this on, and it passed. If it doesn't pass, there could be a few things that went wrong. Maybe you cut into the wires too deep, or you color coded the connector on wrong. But these things are really easy to fix as long as you catch them before you permanently install them. Along with the cable tester, you'll eventually need this device called a probe. A probe is used to detect wire that can't be seen. So for example, if it's behind a wire, or if this cable is intertwined with a bunch of other cables, a probe will help you identify the exact cable you're working with. So in order to use a toner, you'd plug in one end of the cable into the main device and then activate the toning mechanism. Once you've done that, you can guide the probe along the general area of the cable and it'll hone in your cable like this. The louder it gets, the closer it is to your cable. So now that we've reviewed all of our tools, let's start wiring and create our first patch cable. Now we're going to learn how to make one of these. These are called patch cables. Like we saw earlier, they're used to test cable to make sure they work properly before they're installed. The method for creating a patch cable is the same as creating a full length cable. The only obvious difference being the length of the cable. So this section is pretty much going to show you everything you need to know in order to install connectors and create operational cables. That includes splicing wires, cutting them, color coding, crimping, all of that. So let's get right into it and cut off a piece of cable. So in order to create one of these, I'll start off by cutting off some cable from my spool. Around 1.5 to 2 feet should be fine. I have this short piece over here that I cut off earlier, so I'll just be using this. As you can see, there's already some wire sticking out from this end, so I'm just going to cut that off. Now we have exactly what you'd have if you cut off a small length of cable. Now, I've seen some beginners measure out where they're going to cut like this by using an RJ45 to measure where they'd cut the sheath, then simply strip the wire and add the connector. You wouldn't do that professionally because you could ultimately end up with some damaged wire if you use that part of the cable. So I'm going to show you how to do this the right way. I'll start off by cutting off some of the shielding. This will be a lot easier if you have good, sharp scissors. Like I mentioned before, these scissors are purely for demonstrational purposes. I would not use these on a job. Once you see some tears, just rip it right off. Now we have our exposed wire and nylon cord. Take your scissors and cut a small slit into the shielding. You're going to use this as a guide for your nylon ripcord. After ripping off more of the sheath, you'll want to cut off the part of the wires that you spliced into with your scissors. This is what I meant earlier when I said don't initially measure with the connector. Using the part that you cut into with your scissors could save you some time, but it's ultimately going to come back to haunt you if one of your tests fail. At this point, you want to make sure that your shield is longer than your wire, just to be extra certain that there's no damaged wire left in the cable. Slowly open up the sheath a little more using your hands. Now you can use the connector to measure where the sheath should end. You're eventually going to want to cut off a few millimeters of wiring to make sure that they're even at the top. And we'll be using a crimper to do that in just a minute. Remember, you don't want any exposed wire between the sheath and the connector. Once you've measured the length of the sheath and determined where it should stop, go ahead and cut it off. These scissors are pretty big, so I'm just going to take my time. At this point, I'll just cut off the nylon cord and I'm done. The wires are exposed, measured, and ready to be installed into a connector. Let me pause right here and mention that with Cat 6 cables, you want the plastic rod in the middle to end exactly where the sheath ends. So, right here. You don't want any plastic rod sticking out past the sheath. And since the sheath will be covered by the connector, the plastic rod shouldn't be exposed either. A lot of this will go much faster when you've done it a few times. Eventually, you won't even need to measure using RJ45 connectors. You'll be able to eyeball them easily. Okay, now that we have access to our inner wires, we'll want to start untwisting them. Now that we're looking at a neat 8 wires, our next task is to arrange them properly by color code. Just like with the jacks, there are 2 different patterns you can opt for. Neither is better than the other. For this video, I'll be creating connectors using the B pattern, which is orange-white, orange, white-green, blue, white-blue, green, white-brown, and brown. Once you've got them in the proper order, the next thing you'll want to do is group them together, as close together as you can. Grab them by the end and give them a few gentle bends to ensure that all the wires are neatly flattened. All 8 wires have to be in a neat row in order to fit into the connector. Give the colors a quick review and make sure they haven't shifted. Then insert them into the bottom blades of the crimper tool with a very little amount, like 2mm sticking out the other end. Now press down on the crimper, but don't squeeze so hard that you cut them. Holding your wires in place with the crimper, wiggle them around a little bit and straighten them out. Make sure the tips are close together too. Then make the cut. Sometimes the wire can look uneven if they bend a little, like my blue wire, but that's okay. They'll straighten out once the connector's on. So that's pretty much all there is to color coding. Now that the wires are even and ready, we'll install the connector. Now that our wires are even, you can see that they simply slip right into the connector if you arrange them properly. Now, granted, slipping it in like this without a problem usually takes a little bit of time and practice. You might have to fill around with it a little bit if it's your first time. As you can see, there are tiny sockets on the end of the connectors to receive the wires. Make sure you review your colors. Check to see if the ends of the wires are actually touching the end of the connector, and make sure that the sheath goes into the connector and that there is no exposed wire. When you're wiring a connector, make sure the release button is always facing you. Once again, make sure you review the colors. Now bring out the crimper and insert the connector into its slot. Make sure it's in there all the way. Then all you have to do is crimp and squeeze down. Now the connector is securely fastened to the cable. You can't even pull it off anymore. It's now a permanent install. And there you have it. That's how you properly install a connector. In the next lecture, I'm going to be going over the other side, but we're going to be doing it a lot faster. Okay, so now it's time to do the same thing on the other side. Like I said, I'm going to be going through this one a lot quicker since it's pretty much a review of the first side. So cut off a small part of the sheath, rip it off, cut a small slit, manually rip off a larger portion of the cable, rip off the part where you spliced in, rip off a little more of the sheath, cut the part of the wiring where you spliced into the cable, peel off a little more of the sheath, measure the connector size as a reference, and cut off the rest of the sheath. Now start on twisting all 4 wires. Once you get the hang of it, you can arrange them by color as soon as you start untwisting them. You don't need to, but it just shaves up a couple seconds. Again, it's white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. Grab and bend them a bit. Now bring out the crimper, make sure all the wires are together, and make the cut. Cut off any excess nylon too. Make sure the wires are straight and even. You may have to recut them sometimes. Now I'll just slip it into the connector and confirm that all the wires are properly inserted. And grab the crimper again and crimp the connector. Now that the second side is done and secure, we have a patch cable. Physically it looks legit, but next we'll have to test and see if it actually works. So now we're going to go ahead and test our newly made patch cable. I'm going to grab my cable tester over here, take one end, insert it into the terminator port, put the other end into the main device, and let's see if it passes. So as you can see, the cable I just made passed. So if yours doesn't pass, there could be a few things that went wrong. The most common I can think of are improper color coding or maybe uneven wiring so that the wiring doesn't touch the end of the connector. Or it could be a case where that cable simply doesn't work. And if it is damaged cable, you'll need to get your hands on some new cable. That's pretty much the only solution. This method that we use to create a patch cable is exactly what you use in order to test a new spool of cable. So if you went out and just got a 300-foot roll of Cat 6 cable and started installing it without testing it first, it could be really painful to find out that it doesn't even work. So always create a patch cable and test your cable before installing them. So now that we've learned how to create connectors and male-to-male Ethernet cords, let's take a look at jacks. So now let's get to our jacks, the female end of the RJ45 socket. For this, I also have another piece of scrap wire that I just have laying around. It's got a connector attached to one end of it, but we're not going to worry about that just yet. For now, all I'm going to focus on is installing a jack to the other end of this cable. I've already went ahead and properly cut the sheath and untwisted the wires on this side too, using the method that I used before. So grab the jack and you'll notice that there's a A pattern and B pattern prominently displayed on each side of the jack. So as you can clearly see, the top is the A pattern and the bottom is the B pattern. Just like with the connectors, we'll be using the B pattern. Like I mentioned, when you're doing a wiring job, you want to make sure that every single cable that you create is the same pattern. And as you already know, the installation method is the same regardless of pattern. The only difference is the actual color pattern. So like with the connector, you don't want any exposed wire between the jack and the end of the cable. So make sure the cable's within the jack like this. Once the cable is kind of secure, you'll want to take each wire and push it into its own slot with your fingers. The last one, closest to the cable, could be a bit tricky if the sheath extends into the jack pretty far, like mine. Just gently wiggle it in. So now we've got this entire side wired. Give them a little push and make sure they're not going anywhere. Just make sure they stay in place for now. We'll be permanently securing them soon. I'm also going to cut off the ripcord before continuing. Now the other side. White, brown, brown, light blue, blue. Also, try to work with the wires. I just took off the top two wires to fit the bottom two first, just because the wires were getting a little too tangled near the end of the sheath. You'll see what I mean when you're actually doing this yourself. Just try to maneuver the wires so that you're not tangling them at the end of the cable. So now we have all our wires loosely secured to the jack. In the next video, we'll be using the punch down tool to secure our wires. So now that all the wires are fitted, you'll want to place them on a hard surface, like a table, a desk, anything that's hard. Don't do it on anything fragile or your hand or your knee. Place it on the floor if you really have to. The punch down tool uses an impact method, so it's in your best interest to use something stable. So now I'm going to grab the impact tool and reveal the blade. This is really one of the most common types of impact tools out there. It's really simple, with only one real changeable setting being the amount of force that is used upon impact. Again, make sure that you have the 110 blades used for Ethernet cables. When you punch down, you'll want to make sure the cutter side is always facing outward. Take the blade and insert it into the first slot like this. Then, depending on the tool you have, you might want to be standing up. Push gently but precisely. Once you've pushed in a little bit, it'll hammer down and simultaneously secure and cut the wire at the same time. I'm using a lower impact force, so it might not fully cut all the wires every time, but it's okay, you can usually just flick it off. Now we've got to do the rest. Sorry, it's kind of hard to position the jack for the camera while punching down. I'm standing up for this too. So now that we've properly secured one side of the jack, let's do the other side. Wiggle it around a few times too to make sure that the wires are nice and snug when punched. Once you've punched down all the wires into their ports, rub off any excess wires and you're pretty much done with the jack. The last thing you'll want to do is cover all these exposed wires. Your jack should come with a cover like this. All you really have to do is secure it over the wires. There will be two tabs on each side to receive the cover. Here and here. But before I fasten this cover, I want to test the jack to make sure it works. And in order to test a jack like this, I'll need to install another jack to the other end. So just like in the previous section, I'm going to go through jack installation one more time. And just like before, it'll be much quicker since it's simply a review. Okay, now we're going to install the jack on the other side of this cable. First, I'm going to cut the connector that's on the other end. Once again, we open the cable and expose the cable. Bring out the second jack. Properly install each wire by color pattern. And punch them all down. Now we've successfully created a female to female Ethernet cable. I'm sure all of you know what comes next, testing. So I'll see you in the next video. So now it's time to test the cable we just made. To do this, grab your tester and the patch cable you made earlier. By the way, you're going to need 2 patch cables in order to test your new cable. So I'm going to insert my first patch cable into the main device, plug the other end into the cable we just made, and make sure it's secure since both the connector and jack are brand new. Grab the second patch cable and plug it into the other jack, and plug the other end into the terminator port. Make sure it's hooked up like this. Of course, yours is going to vary depending on how long your cables are. Just to reiterate, make sure you've tested both patch cables before doing this to test the jack to jack cable, just to ensure that if the connection fails, we know that it's the jack cable's fault. So I'm going to start up the tester, and it passed. So now that I know that both jacks are functional, I can go ahead and cover them up. Like I mentioned earlier, line the 2 little tabs and just push it right in. And that's all there is to it. So when you're installing these in a building, you'll most likely be using plates like these. All you have to do to install these is basically insert the jack through the back end of the plate. There's going to be a little tab at the top of the jack to secure it into the plate. I won't be installing it onto this wall plate to show you, but all you really have to do is push it past the tab. It's really simple. And that's how you create RJ45 jacks. Okay, so pretty much every cabling job you encounter is going to be different. Different building, different demands, etc, etc. I've already went through all the actual wiring specifics. The only thing left is actually running your cables. Again, this will depend on the setup you're cabling. For example, if you're simply installing a wall jack, you might create a female to male cable, plug it into a modem, run it through the walls, and install the plate with jack onto the wall. For installing plates into drywall, you also might need a small drywall saw. They're actually really handy for cutting precise shapes. Remember, make sure your cables don't run past 100 meters. So always measure them and ensure that all cables will reach their target first before creating and running the cable. It should always be one continuous wire from point A to point B. Don't splice two Ethernet wires together even if they're under 100 meters long. Also, when you're running cable, keep a close eye on it and make sure it doesn't crimple up or bend at any point. Crimpled wire like this can end up compromising the entire cable, so always have an eye on your cable when you're running it. There's not much else to running cables. Always use your best judgment when you're out there working in the field. I'll definitely be updating this section in the future with more videos as I come across more unique cabling jobs. Congrats on making it to the end. I've officially taught you everything you need to know about network cable termination, installation, and testing. It's pretty easy, but it's not something that can be rushed at all. That reminds me, neatness counts, especially when you're working for a client. You want your work to be easily understood by the next technician after you. You don't want them to be telling your old client that you did a messy job. So when running multiple cables, always use zip ties and keep your cables organized. If you need to, label them too. And again, it should always be one continuous cable from point A to point B. So that's really all I have to say about cabling. It's a pretty easy gig once you get used to it, not to mention profitable once you've acquired a bit of credibility. Anyways, as always, if you have any questions at all, please let me know in the Q&A, and I'll do my best to answer your questions. Happy cabling!